Physics 2212, Lab 2, Charge Tape Revisited. Overview. First, we'll get into a brief introduction, then we'll look at the physics involved, then we'll observe the observed motion, and then we'll look into our computational motion determined from the glow script model, look at the results that we took away from this, and answer some fundamental questions to gauge our understanding over the topic as a whole. Introduction. Purpose. The purpose of this lab is to gain an understanding of the interactions between charged objects, the tape, and compare these observations with that of a simulated model, and then predict the tape's charge and predict its surplus or shortage of electrons. In this lab specifically, we also take a look at the differences between looking at the charges of the tape as a point charge model and as a line charge model. Results preview. The positive charge of the tapes resulted in their repulsion of each other when brought in close proximity, determined to be positive charge because it was attracted to a plastic pen with negative charge. The electric charge on a single tape is 5.93 to the E negative 9 coulombs, and the tape was deficient of 3.7 E10 electrons. Physics involved. Fundamental principles and equations. So some of the equations involved in this lab are Newton's second law, the gravitational force, and Coulomb's law, as well as the formula for a line charge. Observed motion. Experiment. The system in this experiment is tape B, and the surroundings are tape A and the Earth. The initial conditions were that the mass of the tape was 2e negative 4 kilograms, and the length of each piece of tape was 0.20 meters. Observations and calculations. The distance between the tapes when E force was applied was 0.0127 meters, and the charge of the tape was determined to be 5.93 e to the negative 9 coulombs, and the number of electrons it was deficient of was 3.70 E10 electrons. Computational motion. So these are some screenshots I took from my glow script model. Clearly this code is very different from last lab, as we use different formulas to approximate the charge. And the formulas we used here are obviously quite a bit longer. You can see some of it after the header function to create a line of charge, and then everything following that is where we created the calculations in the code. Results. Here are the results from my lab. The calculated charge in the computational model is nearly equivalent to that of the calculations done for the observed model. This is likely because both the observed and computational models relied on the same set of equations, and they had the same input data. Possible sources of error. We assume zero air resistance in this lab, and we assume that both pieces of tape had identical charges, which is likely not the case. We also determined that the magnitude of the electric force was 4.7854 to the E negative 5 newtons. Key takeaways. What if? What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. The electric charge of the line charge model is significantly less than that of the point charge model. In theory, this model should be more accurate because it is an integration rather than a point charge. Why? Why do these estimates differ? Which value is more likely to be closer to the real value, and why? As stated previously, both models rely on different sets of equations, with the line charge model relying on integration techniques to determine a more exact approximation for the electric force. Thank you.